Welcome to Object-Oriented Analysis and Design. After watching this video, you will be able to explain what objects and classes are, describe the purpose of a class diagram, and explain object-oriented design in relation to software architecture. Object-Oriented Analysis and Design, or OOAD for short, is an approach for analyzing and designing a software system when the system will use object-oriented programming languages to develop it. So, before we discuss OOAD, let's learn a little more about object-oriented programming in languages like Java, C++, or Python. At the heart of OOAD are objects. Objects contain data, and they also have behaviors that prescribe the actions the object can take. I could create an object, for example, that represents a patient. And let's say that patient's name is Naya Patel, and Naya needs to cancel an appointment she made. Before creating Naya, however, we must first create a generic version of a patient object. The generic version of an object is called a class. Let's discuss classes next before we discuss more about Naya. Specific objects, also called instances, are created from classes, which are blueprints or templates for an object. So, from our previous example, considering Naya Patel, Naya would be an instance of the patient class. The class contains the object's generic attributes, the properties and methods, but it is only when the object is created, which is called instantiation, inside the code, that these generic attributes are set to particular values. So, the patient class might have a variable called last name, which is a property, but does not specify what that last name is. Last name is just a placeholder until the object is created and assigned a name. And once the object has been instantiated, its methods can be called to make the object perform some action, such as making or canceling an appointment. OOAD is used for a system that can be broken down into objects that interact with each other. In this way, multiple developers can work on different aspects of the application at the same time. As noted earlier, visual UML diagrams can be created that show both the static structure and dynamic behavior of a system. We've seen a couple of examples of behavioral UML diagrams already, so now let's look at a structural UML diagram called a class diagram next, now that we know what classes are. This is an example of a class diagram. Class diagrams are commonly used to communicate a software system structure in OOAD. The class diagram shows how the classes in an object-oriented design relate to one another. Each box represents a class and shows its attributes. Recall that an object's attributes are both its properties or its data and its available actions, called methods. A class diagram also shows the relationships between classes. A subclass is said to inherit its parent class attributes, meaning it has the same properties and methods as the parent class, but also may add additional properties and methods. In this diagram, the nurse, doctor, and technician classes are subclasses of medical personnel, and the specialist class is a subclass of the doctor class. This means that doctors can do anything medical personnel can do, and specialists can do anything a doctor can do. In this video, you learned that object-oriented analysis and design is the process of planning a software system based on the behaviors of interacting objects. Objects contain data, and they also have behaviors that prescribe the actions the object can take. Classes are blueprints for objects, and a class diagram is a structural UML diagram that shows the relationship between objects.